Hello and welcome. This is a presentation on conducting correlational analysis. My name is Daniel Garcia, and this was for a class in business research methodology and quantitative statistics at California Intercontinental University. So just a little background on the data here first that we're going to get into. The data set was generated using a SurveyMonkey survey asking participants that were located in the Midwestern United States questions regarding their income, their debt, savings, and other important personal financial factors. And then we did correlational analyses on these different variables that you're seeing here on the agenda to look for significant correlations. So we looked at income and debt, income and savings, income and stocks, income and wallet, debt and savings, debt and stock, debt and wallet, savings and stocks, savings and wallets, and stocks and wallets. All of these variables were looked at for correlational analyses. And then also at the end of this, we're going to have a slide with the main takeaways. So the first two variables that were studied was income and debt. We did not find any significant result between these on the data items. The null hypothesis in this case would state that there is no correlation between income and debt. The alternate hypothesis that there is a correlation between income and debt. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05, and no significant correlation did emerge, as I stated. The R value was negative 0.05 and the p-value was 0.535. So the test failed to reject the null hypothesis and concluded that there was no correlation between income and debt. On our second hypothesis test, we looked at income and savings, and we did find a significant correlation between these two items. So the null hypothesis stated that there is no correlation between income and debt. The alternate hypothesis, there is a correlation between income and debt. The correlation coefficient and its p-value, again, calculated using PSPP and assuming a alpha level of 0.05. We did find a significant correlation with the R value of 0.91 and a p-value of 0. The test rejected the null hypothesis, and we concluded there was a correlation between income and debt. For the third hypothesis test, we looked at income and stocks. The null hypothesis stated that there is no correlation between income and stocks. The alternate hypothesis that there is a correlation, or that there would be a correlation between income and stocks. Again, this is going to be constant with all these. We used PSPP and assumed an alpha level of 5. We did find a significant correlation here between income and stocks with an R value of 0.19 and the p-value of 0.018. So we were able to reject the null hypothesis and conclude that there was a correlation between these two variables, income and stocks. On our fourth testing, we looked at income and wallet, and we did find a significant result here. Wallet, I should just mention briefly, this one's not quite as maybe obvious as the other variables, but wallet was how much money an individual or participant reported that they carried, average amount of cash or money that they carried in their wallet with them. So on this test, we considered that the null hypothesis was that there would not be a correlation between income and the amount of money in the wallet, and the alternate hypothesis that there would be a correlation between a person's income and the amount of money in their wallet. And we did find a significant correlation with an R value of 1.00 and a p-value of 0. So we were able to reject the null hypothesis and conclude that there was a correlation between income and wallet. On the fifth hypothesis test, we looked at debt and savings. And the null hypothesis, there is no correlation between debt and savings. On the alternate hypothesis, there is a correlation between debt and savings. So on this correlation test, we did not find a significant correlation with an R value of negative 0.03 and a p-value of 0.748. So the test failed to reject the null hypothesis, and we concluded that there was no correlation between debt and savings. On the sixth hypothesis test, this time looking at debt and stocks, the null hypothesis, there is no correlation between debt and stocks. The alternate hypothesis that there is a correlation between debt and stocks. And again, I should probably give a little background here briefly that Stocks represents those participants who stated that they own stocks and kind of the amount of money that they had invested in stocks. So in this test, we were looking to see if there was a correlation between the amount of debt somebody had and the amount of money they had invested in stocks in the stock market. So we did not find a significant correlation here. We had an R value of negative 0.05 and a P value of 0.555. So the correlational test failed to reject the null hypothesis, and we concluded that there was not a correlation between debt and stocks with these study participants. Next, on the 7th test, we looked at debt and wallet. Again, similarly, debt and wallet, how much debt that person reported that they had, and how much money they carried in their wallet. We testing to see if there was a correlation between these two variables. The null hypothesis stating that there is no correlation between debt and wallet, and the alternate hypothesis that there would be a correlation between debt and wallet. We did not find a significant correlation between these two variables. R value was a negative 0.05 and the P value of 0.533. So we failed to reject the null hypotheses and concluded that there was no correlation between the debt and wallet variables. On the 8th hypothesis test, we looked at savings and stocks. So here, how much money the participant had in savings versus how much they had invested in the stock market. Were these two variables correlated? The null hypothesis said there is no correlation between savings and stocks. The alternate hypothesis that there is a correlation between savings and stocks. So we did find a significant correlation here with an R value of 0.28 and a P value of 0. So we were able to reject the null hypothesis and conclude that there is a correlation between savings and stocks. On the 9th hypothesis test, we looked at savings and the amount of money in the wallet. The null hypothesis stated that there is no correlation between savings and wallet. The alternate hypothesis that there is a correlation between savings and wallet. So we again here we find a significant correlation, an R value of 0.91 and a P value of 0. So we're able to reject the null hypothesis and conclude that there was a correlation between savings and wallet. And finally, on the 10th test, we looked at stocks and wallet. And we found a significant result here. The null value was stated to be that there would be no correlation between stocks and wallet. And the alternate hypothesis that there would be a correlation between stocks and wallet. There was a significant correlation with an R value of 0.19 and a P value of 0.017. So we were able to reject the null hypothesis and conclude there was a correlation between these two variables of the stocks and wallet. So the main takeaways from the results of this data analysis, PSPP, which is the tool that we used, allows users to analyze data sets and determine correlational significance amongst variables. Correlational tests can be used to determine if significant relationships exist between variables and what the strength of those relationships are, either positive or negative. So specific to this data set, 6 of the 10 data items were shown to have a correlation amongst the studied variables. The notable exception, this is interesting, was that the variable of debt was not found to have any significant correlation with any of the other variables. And that was only true for debt. The other variables of income, savings, stocks, and wallet were all found to be significantly correlated with each other. Thank you for watching. Are there any questions?